Hello geometry students. In this video I'm going to take you through some of the properties that we've been discussing in class, and I have one short proof to kind of give us an introduction to this proof unit that we've been starting. The first property that's going to come up every now and then in the proofs that we do has the form where something is equal to itself. In this situation we call it the reflexive property of equality. Additionally, we're going to see some type of proofs that involve us to change the order of an equation. If the measure of angle A is equal to the measure of angle B, then we're allowed to switch the order here. We're allowed to say that the measure of angle B is equal to the measure of angle A. And this is the symmetric property of equality. And last, one of the most common properties that we're going to be using, if A is equal to B and B is equal to C, then logically speaking we can say A is equal to C. And we've seen this before in our law of syllogism, where a statement A is equal to B, then B implies C. So the example that we've been using in class, if you run, you sweat, and if you sweat, your hair gets gross. So we can logically say, if you run, then your hair gets gross. This is the transitive property of equality. Transitive property of equality. The next two properties has this form. If AB is congruent to CD, then we can say that AB is equal to CD. So here we're really hitting on the difference between congruence and equality. When we talk about two line segments being congruent or two angles being congruent, we're just talking about that. Lines are congruent in themselves. So line segment AB is congruent to line segment CD. Essentially, these are the same line segments, or the same line. If we know that the lines are the same, then AB equal to CD is talking about their measures, talking about the numbers involved. Same thing here. If angle A is congruent to angle B, then certainly their measures are the same. So when we use congruence, we're typically talking about angles, lines, shapes, and we reserve equality for numbers. This top one is the definition of congruent line segments. And down below, the definition of congruent angles. Alright, quick example of a proof using these definitions. Given measure of angle A equal to measure of angle B, and the measure of angle B equals the measure of angle C, prove that angle A is congruent to angle C. For the first statement, we're going to start with what we're given. So we're going to say measure of angle A is equal to measure of angle B. Similarly, measure of angle B is equal to measure of angle C. And our reason for that, it's the given information. This was given. From here, what we notice is we have two measure of angle B's. So by that law of transitivity, by the transitive property, we can say that the measure of angle A is equal to the measure of angle C, the transitive property. The transitive property. If the measures are the same, then using the definition of congruent angles, which we just discussed, we can say that angle A is congruent to angle C. Definition of congruent angles. That's what we just learned. So we started with our given information, applied the properties that we discussed, and reached the conclusion that we wanted to show.